Hey guys, and welcome back to an episode where today we're doing more math exam review. This is chapter 2 or part 2, and we're going to start off by talking about transformations of quadratic functions. This is where you take a function that is in vertex form. For instance, f of x equals 3x plus 2 squared plus 1. Now, we're going to take this equation and put it into something that you can actually graph without a calculator. If you have a calculator, you can just plug that in and it'll give you the points. But this is how to solve for the points without a graphing calculator. So, first off, if you take these are going to give you your bottom point of the u. It's going to give you this point right here. And since this is going to be 2 to the left, so this is going to be negative 2 and then positive 1. It's going to be negative 2, positive 1. That is the bottom of the u. Now, we don't know how the other points are going to be. So you have this point of the u, but you need to find a couple of these points. And this is how you do it. You take first this equation and just plug in a random number. For instance, this case, I'm going to be using 0. So I'm going to be f equals 3, 0 plus 2 plus 1. Now, 0 plus 2 is, of course, 2. Just square that. That's going to be 3 times 4 plus 1. That, of course, is 12. 12 plus 1 equals f. And this is going to be f equals 13. 13 is going to be the y. So our first point will be 0, 13. So we have our main point down here, our next point over here, and now we're going to solve for one more point. We just need 3 points to a parabola. This time we're going to be plugging in negative 1. So f equals 3 minus 1 plus 2 squared plus 1. Now, negative 1 plus 2 is 1. 1 squared is 1, so it's going to be 3 times 1 plus 1. This, of course, is going to equal 3 plus 1. That's 4. So f equals 4. That is our second point, where since we have a negative 1 here, it's going to be negative 1 in the x place and 4 in the y place. So now we have the bottom of the parabola. We have 2 points, and when you graph it, it should look like this. Let's just go with 1, 2, 1, so it's like right there. And then negative 1, 1, 2, 3, 4, something like that. But then you'd also match that over here because it's reflected on the negative 2 x-axis line. And then we'd have 0 and 13. Let's just say 13's up here. And right here. So we'd have something that looks like this. Just shape like that. And that's how you solve for this equation, but without a calculator on a graph. Next, we'll be looking at writing transformations with only them stating what we need to use. So, for instance, we'll start off with just f of x equals x squared. Now, let's just say that they want us to do a vertical shrink. I'm just going to say a VSH for vertical shrink of 1/3. And then they want us to go up. They want us to go up 1. And they want to do a reflection of the x-axis. I'll just put x-axis. You don't need equal set. And then going to the right 3. So this is R3. So they want us to do a vertical shrink of 1/3. They want us to go up 1. They want to do an x-axis reflection of that. And they want us to go right 3. So we just need to plug that into this function up here. How do we do that? Well, first of all, let's just take x squared going to the right 3. So it's going to be x, that's a little big. Let's just go x minus 3. That's going to the right 3. Now they want us to go up 1. Let's do plus 1. This is a quadratic function, so gotta get the x squared. And they want to do a reflection of the x-axis, which means just do that. But they want us to do a vertical shrink. So it should look something like this. F of x equals negative 1/3 times x minus 3 squared plus 1. That is how you turn this equation up here, add all these to it to get this equation. Next, we're going to take the same form, vertex form, which is the y equals a x minus h plus k. Make sure it's squared in parentheses. So a times x minus h squared plus k is vertex form. Now, from this, we'll just look at how to get the axis of symmetry. So we can take our vertex from an equation that they've given us, which is y equals 2x plus 1 squared minus 3. Now from this, we can get our vertex, which is going to be negative 1, negative 3. Because we need to go left 1 and then down 3. There we go. There's a vertex. Now our axis of symmetry is going to be negative 1. Because when you put that on a graph, let's just say negative 1, it's right here, then 1, 2, 3, right there. Now, I'll talk about this later, but since this is a positive, the u is going to be facing upward. When you get the axis of symmetry, which would be the middle point between going down and going up. So that's also right here, right through negative 1. That is, if you flip it on the y-axis, it will look the exact same. Now, let's just plug 0 in for x just to get some more points on the graph. You don't have to do this when you're solving just for axis of symmetry, but it is a good idea to get a more exact location. So let's just do y equals 2, 0 plus 1 squared minus 3. Okay, 1 squared is just 1, so it's going to be 2 times 1 minus 3. 2 minus 3 equals negative 1. So when you have negative 1, this is going to be your y from right here. Y equals negative 1. Put in a 0 right there. First points are 0, negative 1. The real graph would look something like this. It would go down through this point, through that point, and back up. Okay, going on to the next one. We need to graph in standard form. Standard form, if you don't know, is f of x equals ax squared plus bx plus c. Now, when you get this, you need to solve for x. So let's just get a number in here. Y equals 3x squared plus, let's do minus 6x plus 4. Now, this is in the same format as standard form, but now we need to get x because we have two x's and we don't know what they are. And to do this, we need to use the equation negative b over 2a. So we have negative 6 and we have 3. Minus negative 6 will be a positive 6, so it's going to be 6 over 6, because 3 times 2 is 6. That equals a 1. So now we know that x equals 1. So we can just replug it in. 3 times 1 squared. And 6 times 1. When you plug in 1 for both, it's going to look like that. It's 1 in parentheses, so 1 squared equals 1. That makes it 3 minus 6, because 6 also times 1 is still 6, plus 4. Now we got y equals 3 minus 6x plus 4. Now, that's going to be negative 3 plus 4, which means y equals 1. So, now we know that y equals 1 and x equals 1 from x and y. So now we know that our vertex is going to be 1, 1. And we also know that our axis of symmetry is 1 because our x is 1. If we were to go through another point, our y-intercept would be 4. So it would be 0 and 4. Because this 4 right here is the y-intercept, which means x is 0 and y-intercept is 4. So we got our vertex and our y-intercept. Next, we're going to find the points of this new equation, which is intercept form. Now, intercept form is f of x equals x minus p and x minus q. So from this, now we just take this and just plug in some numbers. Y equals 3x minus, let's do plus, x plus 2 and x plus 6. Now, straight away, we need to figure out what x is. So we need to take p and q, we need to just add them together. And to this we do, we need to add them together and divide them by 2. Because that's how you solve for x with the intercept form. So it's going to be p plus q over 2 equals x. So let's just plug them in. It's going to be, since it's inside the parentheses, of course, it's going left. So you need to make them negative when you do plug them into this equation. So it's going to be negative 2 plus negative 6 over 2. That is negative 8 over 2, which is going to be negative 4. So now I know that x equals negative 4. And we can just plug that in here. So I'll just up. And it's going to be negative 4 and negative 4. So negative 4 plus 2 is going to be negative 2. And negative 4 plus 6 is going to be positive 2. Let's write those in there. Parentheses first. And you get negative 4 times 3, which is going to be negative 12. Okay, that's a bad 12. Negative 12. Y equals negative 12, and x equals negative 4, so it's going to be negative 4, negative 12. That is going to be the bottom part. That's going to be the vertex, which is going to be the bottom part of the parabola. But also, we need to find our x-intercepts, which luckily enough for us are P and Q. So our first x-intercept is negative 2, 0. And our second one is going to be negative 6, 0. So now we have our vertex and our x-intercepts. Next, like I said before, we're going to find our minimum and maximum values. This is a part where you can tell straight away if the shape of the line is going to be either going up like this, or if it's going down like that. Going up like this has a minimum value because that's the lowest it can go. Having a graph like this has the maximum value because you can't go above that, you just go straight back down. So you can tell straight away if it's going to be a minimum or maximum value by A. If A is positive, that means it's going to look like this and it's going to be a minimum value. Now if A is negative, it's going to be a maximum. So you can tell if it's going to go up and then down. Let's get an example up here. Let's go with f of x equals 3x squared plus 18x minus 5. Now this is a standard equation, and you can tell from A right here that it's going to be a minimum value. It's going to look like that. So, of course, straight away we need to figure out what x is, so we're using the equation negative b over 2a. Negative b is going to be negative 18 over 6, because 3 times 2 is 6. Okay, well, this equals negative 3. So we know that x is now negative 3. We can just plug it straight away right back in the equation. Okay, negative 3 squared is going to be negative 9. Negative 9 times 3 is going to be 27. So let's just write it down here. So 27 minus, because it's negative 3 times 18, minus 54 minus 5. So you add them all together, and eventually you'll get y equals negative 32. So now we can take our x and our y and make 3 negative 32. That is our vertex, and that is the bottom point in our parabola. Negative 3, negative 32. So it decreases to the left of 3, and it increases to the right of negative 3. Our minimum value is negative 32. Our range is y is greater than negative 32. Since that's the bottom part, it's always going to be above negative 32. So y is always greater than negative 32. Okay, so our next one is going to be writing equations using vertex and using the vertex and a point. So imagine we're getting the vertex negative 5 and 9, and then we're getting a random point, which is just negative 7 and negative 15. So we got a vertex and a point. Now, the letters are going to be, this is going to be H, this is going to be K, and this is going to be X, and this is going to be Y. So the equation that you'd plug this into is going to be a vertex form, which is Y equals A, X minus H squared plus K. So straight away, you just start plugging in everything. So Y is going to be negative 15 equals X, which is going to be negative 7. Oh yeah, we don't have A value yet, so we're just going to leave A as A. So negative 7 minus H, but since it's a negative, it would be plus squared, then plus 9. So straight away, you can just factor this stuff, which should get you to, let's just skip ahead because make this quick. 15 equals 4A plus 9. Now, to solve this fast, you just do minus 9 and minus 9. This would get you negative 24 equals 4A. And you just divide by 4. And that would leave you with A equals negative 6. So now that we have A, we'll just take our equation back up here and re-plug it in. So it'd be Y equals negative 6 outside the parentheses of X plus 5 and plus 9. And that is how you solve an equation. Yeah, that's how you make an equation out of just the vertex and a point. That's the answer. Okay, and this is going to be our last one where we are going to be writing equations using a point and x intercepts. Now, this is basically exactly like the last one we just did, but we're using a different equation. We're using f of x equals a x minus p and x minus q. Now, of course, this is the intercept form. So, I think it's easy to distinguish which ones are which because the one we just did was using a vertex and a point, and we used a vertex equation. This one is to find a point and an x-intercept, and we're using the intercept form equation. So, let's just say our x-intercepts are 9 and 1. That would look like if you were using actual points, it would be 9, 0, and 1, 0. And then we'd have our random point, which would be 0 and negative 18. Now this would be P. Number 1 would be Q. This would be X, and this would be Y. So now we got P, Q, X, and Y. We can just start plugging it into the equation up here. So Y would equal negative 18 equals A 0 minus 9 and 0 minus 1, like that. Then we just solve. This is going to be negative 1. This is going to be negative 9. So negative 1 times negative 9 is just 9. So you get 9A, negative 18, like that. Then you just divide 9 divide 9, negative 2 equals a. From this, just plug it back in. Y equals negative 2, x minus 9, and x minus 1. There you go. That's how you solve from a point and then two x-intercepts. Okay, thank you guys for watching. This was Chapter 2 of Algebra 2, and I'll see you in the next episode, or Chapter 3. See ya.